joining us this morning. So Julia Dunkerley, who's the Principal Advisor at the Changeworks Affordable Warmth Services. Special thanks to Julia, because she was kind of drafted in as a last minute when our other speaker couldn't make it, unfortunately. And then we also have Paul McGee, who's Managing Director at Warmworks. So before I pass over to the speakers, just a few kind of housekeeping items. So when you join the session this morning, your microphone will be muted. If you would, at a later point in the Q&A, like to speak and ask the speaker a question directly, then please raise your hand, unmute yourself and say who you are and where you're from. We also have the chat function as well, so if you have any questions again that you'd like to put in there, then you can use that. We'll make sure we try and get to all of the questions. And again, your video, that's optional if you want to have that enabled or not today, but it's sometimes nice to see everybody. And then just to let you all know, we are recording the session today as well, so that it will be shared afterwards so that others can watch it. That's everything from me just now. So thank you again for joining us. I hope you enjoy the session, and I will hand over firstly to Julia.
Thank you so much, and thank you all for having us today. I'm going to go over a quick sort of overview of air source heat pumps, and then I'll pass on to Paul, who's going to go a bit more in depth. But I think to start off, we're going to do a quick poll, if that's okay. I think that's Molly, you okay to kick that off? So yeah, so just a few questions there, if you don't mind giving us some feedback, just so we can sort of grasp, you know, how you are doing in terms of, have you already provided advice on air source heat pumps? On a scale of 1 to 5, just how knowledgeable you feel you are about air source heat pumps currently, and on a scale of 1 to 5, how confident are you speaking about air source heat pumps? So if you don't mind just taking a moment or two to complete that for us, that would be fantastic. Perfect. Can I get some thumbs up when people have all done that? Lovely. I'll maybe move on now. I think there's a few. All good. Lovely. Right, I'll just kick off with my presentation and make sure you can all see this.
Yeah, we can see it.
Perfect. Lovely. Okie doke. Yeah, so my name's Julia. I'm a principal advisor here at Changeworks. And I'll just go through some of the ins and outs of air source heat pumps, and I'll take questions at the end if you want to put some in the chat box, and I'll get to them at the end as well as we go. So just starting off a little bit about Changeworks and what we do. At the core of it, we're an environmental charity. Our mission is to develop and deliver high impact solutions for low carbon living. We have over 30 years of experience in helping to make Scotland a positive low carbon living a reality. We are based across Scotland, in the Highlands and Islands and in South East Scotland. We have over 200 enthusiastic employees and volunteers in Edinburgh, Inverness, Shetland, Orkney, the Western Isles and Argyll, so we're all over. Air source heat pumps, so basically they can play a big part in Scotland's road to net zero. Heat pumps are more efficient than other heating systems because of the amount of heat that they produce is often more than the amount of the electricity that they actually use. The amount of heat produced for every unit of electricity is known as the coefficient of performance, COP, in other words. So if a heat pump has a COP of 3.0, then it will give out 3 units of heat for every unit of electricity consumed. For a comparison, a new aerated gas boiler could be a COP of up to 0.9, so quite a difference in terms of efficiency. So this is why many housing associations are moving towards air source heat pumps to replace not just the older electric systems like storage heaters, but also some gas systems. So your air source heat pump works very much like the reverse of a refrigerator. You've maybe heard that before. Basically, the pipes are full of a liquid that can boil at a very low temperature, around minus 17 degrees. So when that liquid turns into gas, this then goes through a compressor, increasing the heat produced. So that heat produced then warms up a water cylinder that then heats the radiators, generally oversized radiators, and hot water within the property. As the air source heat pump runs at a lower temperature compared to gas central heating, the air source heat pump runs a cleaning process usually every week to kill the bacteria like Legionella. It runs a sequence every week that basically runs at about 60 degrees to kill off any of these dangerous bugs and bacteria. Now, air source heat pump runs at a lower heat and needs more time to build up within the home. So you'll have a bit more of a lag than you would with, say, your gas central heating system that you're maybe used to. This can take a few hours, and that's why it's best not to turn them off completely. We have found that most people who end up with costly energy bills with an air source heat pumps is because they've sort of not changed their behaviours and have been treating that air source heat pump like a gas boiler, and they turn the thermostat up high, and this is normally because the heat is not instant. You're not getting that instant effect, or the radiators don't feel hot. Radiators that aren't hot can be a benefit sometimes if you've got younger children in the home or elderly. It can also reduce the risk of burns, etc. There are a lot of great ways to control an air source heat pump via their control panel, not to mention smart controls and apps and things like that. But for a lot of people that we support, it can be a bit overwhelming with this technology. So we try and keep the advice as basic as we can in terms of temperatures and how to run the system. So this is generally what your air source heat pump will look like. It's very important for an air source heat pump that you don't place any items in front of it. This will disrupt the airflow to the air source heat pump and could affect its efficiency overall. You should never cover your air source heat pump. That could significantly reduce the airflow, which would cause a massive reduction in the heating efficiency and potentially lead to sort of overheating and failure of components to be able to work. So it's very careful not to obstruct it by any means. Also very careful not to put anything near the fan of the air source heat pump that you can see there behind the cage, to avoid sort of hurting yourself or damaging the pump's components. Taking that all into consideration, the system is very robust and can still operate at temperatures of minus 20 degrees. So to keep it simple, the best advice is that the heating is left on all the time and that the thermostat is manually turned up and down to switch your heating on and off. When you don't want the heating on, the thermostat should be set to about 15-16 degrees. And then when you do want the heating on, up to about 20 degrees. I would recommend that the heating is set to sort of 18 to 20 degrees if you're in the house, and then going down to about 15-16 if you're going to bed. They also have a timing function, so you can set that system to automatically adjust to your lifestyle. And it's important just obviously to note that it does take longer to respond than traditional gas and electric systems again. So maybe worth, if you're using that timer, to set it up a good sort of hour and a half or so before you would want to feel the benefit of that heat in the morning, say. If you're going away on holiday or just switching the heating off for the summer, you could just turn that thermostat down to 10 degrees. That should effectively switch it off. But again, important to not switch it off completely for the sake of the air source heat pump. And again, yeah, it does take a long time to, if it's been at a low temperature for quite some time, say we're switching it on for the first time in the winter, it could take quite a good time to build up some heat, so it's worth noting. So the cheapest tariff for the system is generally thought to be a single rate tariff. Tariffs sort of fluctuate now and again. I've recently been doing this for some clients, and at the moment it's definitely a single rate is looking cheaper, unlike your old storage heaters where the cheaper rate is during the off-peak hours at night. Energy companies are starting to look at air source heat pump tariffs, but these are sort of few and far between at the moment. So stick with that single rate, and the householder will need to inform their energy supplier that their heating system has changed, and they would like to switch to the most economical tariff and meter type, and they should follow through with this and make an appointment to get that meter changed. If the householder is on a fixed tariff, we're talking maybe before the energy price hikes last year, and they've got that fixed tariff for 2-3 years, it might still be worth sticking to that tariff, depending on what that tariff is, comparing it to the sort of standard variable rate. But these can all be looked at and accessed online. So despite the fact that, you know, these systems are renewable, they're efficient, it's still important to be energy smart. We always try and encourage people that are getting air source heat pumps or any renewables to adopt these energy saving behaviors, using low energy light bulbs, only filling the kettle for what you need. You've probably heard that one quite a few times of late. Avoiding standby mode where you can, washing your clothes at 30, limiting tumble dryer use where you can if you use one, and to just bear in mind your thermostatic radiator valves to control each, and to change them suitable to the room. So we always try and encourage these energy saving behaviors despite what technologies you might have. So yeah, so that's a quick roundup. I will, if you do have any sort of questions in relation to sort of you want some personal advice as to what your to renewables, we'd encourage you to call Home Energy Scotland, and they'll be able to advise you best way and funding and whatnot might be available. I think that's pretty much me. I'll look for any questions if there are any at the moment.
Yeah, thanks very much, Julia. Is there any questions you have? If you want to post them in the chat, then we can come back to kind of a Q&A at the end if nobody has anything at the moment. So with that, then I think we'll hand over to Paul then to do his presentation.
Thanks very much.
Thanks, Julia. Thanks, Cassandra. Morning, everybody. I will do the same as Julia and just bring up my slides. I'm a bit of a Zoom novice, used to doing this on Teams a bit more frequently, so I'm hoping that's working for everybody and everybody can see that. Good morning. My name is Paul McGee. I work for Warmworks and have the privilege of looking after our social housing division. And just wanted to talk a little bit more about the support that we can offer people who receive the heat pump intervention technologies, help them to optimize those technologies and try and get the most out of them. Just from a context perspective, Warmworks, we were founded a number of years ago now, initially to deliver the Scottish Government's flagship retrofit Warmer Homes Scotland scheme. But over the last few years, we've also developed a number of relationships with social housing providers to deliver heat pump and other energy saving technologies into social housing properties in order to enhance the energy efficiency of those properties and try to optimize the cost effectiveness of energy bills for their tenants. And our role is as a managing agent, managing the customer journey, overseeing quality control from the perspective of installations, ensuring that tenants and other residents are comfortable, they understand the technologies, they understand any disruption that they may encounter, which of course some heating installations can be fairly disruptive. And we also carry out in-home inspections to verify all of that quality control. We have had a track record over recent years in leveraging social housing net zero heat funding on behalf of a number of registered social landlords. We have a number of projects in progress currently. We have a number of projects that we've already delivered for social housing providers. We've completed in the region of 150 heat pump installations within those projects to date. We'll be installing another 250 plus over the course of the coming year. We've levered in that level of funding from the net zero heat pot with Scottish Government of £5 million to be matched to be able to facilitate approximately £10 million in project spend. And having also gained some additional experience within other areas of delivering heat pumps, we feel like we're in a fairly good position to be able to offer some additional insights into the all that great stuff that Julia talked about earlier in terms of the heat pump benefits and how they get to do what they do. So once we've installed these technologies, we've certainly found over recent years that, Julia mentioned it, and I made a couple of notes on the back of Julia's slides, but Julia mentioned it that trying to keep the advice to people relatively basic is absolutely the right way to go. But there are people that receive these interventions that want to know a little bit more. They are a little bit more tech savvy, and they do want to be making the most of the technology that has been installed. And of course, this technology is pretty modern, it's pretty future facing, and it can sometimes be quite overwhelming. So we have tried to build on the basic level of information, which obviously is the right thing to do across the board. We've tried to build on that level of information in terms of informing people to further enhance the efficiencies and the benefits that they can get from heat pumps, particularly in this instance. And at a slightly lower level of technical detail, there's a couple of key routes that can ensure that heat pumps do work more efficiently. Increasing the runtime of a heat pump. In other words, increasing the time that the compressor that Julia also mentioned earlier is working. Will help the compressor to maintain its peak efficiency. And the longer it runs, the more efficient the heat pump will be, because it will continue to maintain a steady, constant temperature of water from which the heating system can draw. And therefore, it's not having to stop and start at frequent periods, which is again goes back to the concept that Julia introduced, which is getting water warm from a cold position takes a lot of effort, it takes a lot of energy, and therefore reduces the efficiency of the heat pump. So it's really important to ensure that cycling isn't too frequent, switching the heat pump on and off regularly, in the way that a gas boiler is operated isn't the most efficient utilisation of heat pump technology. Equally, again, building on what Julia mentioned, lowering the flow temperature of the heat pump and trying to find probably the lowest comfortable temperature is the optimal solution for residents, tenants, homeowners, because lowering that temperature through the radiators means the heat pump and the compressor doesn't need to work as hard, and as a direct result, less electricity is consumed. So that lowering of the flow temperature, no one's suggesting that anybody should go cold, but finding the lowest comfortable temperature, and most specifically on a seasonal basis, is really important. Without overheating when it's warm outside, but also making sure it gets to warm enough when it's cold outside. That's really key. So the increasing of that runtime to ensure that the heat pump is the compressor is running as long as possible to maintain its peak efficiency without having to stop and start, and then lowering the flow temperature so that the compressor isn't working too hard too many times to continually heat the water, are two very key concepts on that side. So building on that, I've got four, in fact, steps that can be taken by the tenants themselves, the residents themselves, or indeed frontline support people within social housing provider organisations, where we can go a little step further than just ensuring that the system runs efficiently. I mentioned earlier about balancing the flow temperature and the heating temperature inside with when it's cold outside, or indeed when it's warm outside. And heat pumps come with or the majority of heat pumps, certainly the heat pumps that we install, their controls come with a weather compensation mode. And that weather compensation mode is it's a clever sensor, basically, that understands what the temperature is like outside and tries to balance what the temperature can then be like inside. And it raises the water flow temperature and lowers it accordingly, which is generally set at the outset of heat pump installation taking place, and installers will be able to set those, set that weather compensation setting, but that can be tweaked to ensure that the best is got out of the system. Obviously, this is pretty dependent upon considerations around lifestyle. And again, Julia mentioned earlier that utilising a heat pump to maintain levels of comfort in the home is very different to using a gas boiler. We have come across many instances where immediately following the switch over from a gas central heating system to a heat pump fired heating system, where people do try to follow their old lifestyle pattern of taking the dog out in the morning at 7 o'clock in the morning and turning the boiler on, turning the heating on at that point. And when they come back an hour and a half later, expecting the house to be toasty, but it's not quite how a heat pump works. And there's then a little bit of confusion, a little bit of a misnomer that the technology isn't working in itself, which of course isn't the case. So there's lifestyle considerations to ensure that the balance and blend of the timings of when the heating's on and the temperatures at which the heating's on are used to make the most out of the technology itself. I mentioned earlier about setting rooms to a comfortable temperature. Obviously, I know that even in homes with gas central heating, nobody sets their temperature too high, but it has less of an impact with gas central heating systems if you set temperatures too high, than it does with heat pump installations because of that efficiency. So setting rooms to a comfortable temperature is critical, and the local setting of the temperature in those rooms by TRVs on radiators is the best way of doing that. The other thing that just needs to be borne in mind by residents is that if rooms aren't being used, turning TRVs down to off in a room that's adjacent to another room that's being heated will actually lead to greater heat loss from the room that's being heated. So if a resident spends their time in the living room and the dining room isn't usually used, so the dining room radiator that's adjacent to the living room is turned off, there will be heat loss from the living room despite the radiator being on. And therefore, in order to maintain the temperature in that living room where the resident spends most of their time, the heat pump will need to continue working. When perhaps if the temperature in the living room was set to slightly higher, the efficiency of the heat pump and of the water circulating through the system could be maintained at a slightly higher efficiency level. So avoiding that heat loss when rooms are unheated is also important. Optimizing the setback temperature. The setback temperature is the temperature that Julia mentioned earlier, the kind of overnight temperature. When rooms don't need to be heated, again, it shouldn't be that the heating is turned off overnight, a bit like a gas central heating system. The setback temperature is the temperature that you want the heat pump to heat the water to when you're not awake, not spending time in those heated rooms. And we recommend that should be between 2 to 3 degrees below the comfort level, the daylight living levels. Again, to ensure that the cycling of the heat pump can happen. It doesn't happen too regularly, but the runtime of the compressor maintains its peak efficiency just to keep topping up that lower temperature water, just to keep it at a good level, so that when the heating is then turned on in the morning, when people wake up, there's only a small gap for it to bridge in order to bring the heating system up to temperature. And that's the most effective way of getting the best efficiency out of the heat pump. And then similar concept in terms of keeping hot water temperatures, again, as at the lowest level that maintains the level, that the temperature that a resident wants. So no one's suggesting that hot water should only be tepid or shouldn't be as hot as people want it, but even a slight tweak of temperature, going from 1 degree higher to 1 degree lower, can make a difference. And we're talking about optimizing the technology that's there. So being able to tap into that is important. It will make a saving, and any saving is an advantage. So in terms of the communication, the ways of communicating this type of thing to tenants, it isn't necessarily an easy thing. And we've gone through a number of different explorations as to how we can most effectively communicate some of this information. We obviously have to be mindful of the plain English standard to ensure that this kind of information is easy to understand. And when I say easy to understand, it isn't necessarily easy because of the future-facing technology that we're talking about, but certainly at a level that gives people the chance to understand it. We've done quite a bit of partnership training with social landlords and their teams, particularly with first-line responders to calls coming in that say, I can't get my heating system right, or I might have switched it off, or whatever it might be. We've done a lot of partnership training with the manufacturers and staff within social landlords to be able to ensure that they can also communicate on a first line basis to those tenants when they might call up. We do joint visits during installation handovers. We offer the service of ensuring that somebody independent is there when an installer is handing over the system, or indeed completing a post-installation inspection, where we can also do a handover at that point as well, in terms of an explanation of the controls, and in terms of understanding perhaps whereabouts on the continuum of understanding the resident is, in terms of their wanting to be involved in perhaps the lower level detail of settings and controls associated with their new installation. And we can tailor then that advice to them in that way. Perhaps when the hustle and bustle of the installation is finished, we do it at an inspection point slightly later down the line. We also look at the impact that other measures that may be installed at the same time or previously on a property, such as solar PV and battery storage, will have on the heat pump. And you know, these measures that are out there now, these energy saving measures that need to be balanced against tariff advice, against meter setups, and again, in accordance with lifestyles, can really make a difference. And we need to be mindful of those things to ensure that we're giving the right advice and support to people in terms of their usage of their new technologies. And that aftercare support, in terms of supporting tenants with both troubleshooting, with signposting them towards their energy suppliers, any perhaps tariff developments that might be around in the market. As Julia mentioned earlier, you know, some tariff providers are talking about heat pump specific tariffs right now. Some residents and some properties that we've delivered these types of measures to over recent years have actually benefited from their energy supplier not coming and changing their meter and not changing their tariff, just by default, because of the climate at the moment in terms of the different tariff hikes and the spikes in some of those tariffs that people may have been on or may have moved on to if they had been changed. So there's lots of moving parts that are really critical to that aftercare support and that wraparound care of people once these interventions have been installed. And most importantly to us is to really ensure that supporting tenants on this road to the net zero transition and the concept of the just transition is at the heart of what we're doing. It's a concept that, you know, we see and hear quite a lot at the moment, and we feel like we have to push in a number of different areas with meter providers, energy suppliers, DNOs, to ensure that we can bring people along and support tenants and support RSLs with their properties to ensure these interventions can go in, and then to ensure that they actually get the most out of them at both a property and resident level. So that's kind of me, Cassandra. Hopefully that all made some kind of sense, and more than happy to take any questions.
Hey, thanks very much, Paul. Yeah, and definitely did make sense to me anyway. Yeah, so I think we'll just open it up to some questions then. Just to say, we won't share the